Hi everyone! This time we're going to talk about the basic limit laws, and in that we'll see how can we put all these limits together in order for us to compute for this limit problem. Alright, so before we answer this given limit problem, let us know first the different limit laws. So we have here the basic limit laws, which are the identity function and the constant function. So in identity function, the limit of your x as your x approaches the value k is k. So here's the graph of this function for you to understand it clearly. No? All right. So the identity function has a graph of a line, and that line has a slope of 1. So it is called identity because every time your x approaches a number, you get that same number back. So for example, your x approaches 1. And since your x approaches 1, the limit or the function also approaches 1, or the approaching value itself. All right. So if your x approaches 2, then the limit is 2. If it is 3, or I mean, if your x approaches 3, the limit is 3. All right. So if you look at the value of the function in the graph as your x approaches k, you can notice that the value of the function is the k itself. All right. So let's say, for example, this is the k. So of course, it is also approaches the value of the function, which is k. Or in very simple words, you just have to substitute x by its approaching value so that if you are asked to get the limit of the function x as your x approaches k, then the limit of it is k. All right. So the next one, we have the constant function. It is called constant because as your x approaches any value in your x-axis, the function has only one value. And this is the graph of your constant function. All right. Assuming that this is your constant value. So in here, no matter where you look at this line, its y value is always c, or the constant value. All right. So as if you are asked to get the limit of this constant function, so the limit of the constant as your x approaches any value of x, all right. So the always limit of it is the constant itself. All right. So basically, we can use this basic limit laws to answer the given problem in the first part of this video. But of course, we have to discuss the other limit laws. All right. So for us to know the different limit laws, let's start with the function that is we all know that is defined. All right. So the limit of your f of x as your x approaches k, you all know that it is L. All right. And if we know that the limit of another function, let's say g of x, as your x approaches k is m. All right. So if you're going to get the sum of the limits of f of x and g of x as your x approaches the value k, all right. So you're just simply going to distribute the limit of f of x and the limit for g of x. All right. So this are going to be like limit of your f of x as your x approaches k plus your limit of your g of x as your x approaches k. And we all know that the limit of your f of x is L, all right, plus the limit of your g of x, which is m. So simply, if you're going to get the limit of the sum of these two functions, you're just adding the limit of f of x and the limit of your g of x, which is L plus m. And how about if you're going to get the difference of these two functions, the f of x and g of x, as your x approaches k. All right. So simply the same process, you're just going to distribute the limit. So this will become the limit of your f of x as your x approaches k minus the limit of your g of x as your x approaches k. And we all know that the limit of f of x is L, then minus the limit of your g of x, which is m. So basically, if you're going to get the sum of these two functions, you just have to add their limits. All right? This is L plus m. So if you're going to get the difference of these two functions, then you just have to subtract their limits. All right. So with these examples of a not so rigorous proofs of the limit laws, then the limit of the sum and difference, the limit of the sum or the difference of these two functions, all right, as your x approaches the value k, then this will be equal to L plus or minus M. So either way, if you're going to get the sum, then you have to use addition in your limits. If you're going to get the difference, then you have to get the, and you have to subtract your limits of this function. All right. And now, if you're think of getting the limit of the product of these two functions, f of x and g of x, then what is the limit of f of x times g of x? What do you think will happen to the limit of these two functions as your x approaches k? All right. The same process, you just distribute the limit. So this will become the limit of your f of x as your x approaches k times the limit of your g of x as your x approaches k. All right. And the limit of your f of x is L. The limit of this is M. Or simply, if you get the limit of the product of f of x and g of x, you're just simply getting the product of their limits. All right. So how about if you are going to get the limit of the quotient of these two functions? All right. So let's say the quotient, the limit of your f of x over g of x. All right. So make sure here that your g of x is not equal to 0. All right. As your x approaches the value k. So what will happen to this? You're just going to distribute the limit for f of x and the g of x. So basically, this will become the limit of your f of x as your x approaches k all over the limit of your g of x as your x approaches k. All right. And by substitution of the limits of f of x and g of x, so this will become L over M. All right. Now let's look at the situation where your function has an exponent. What would be the function like? So for example, you have I need this one. You have the limit of your function that is raised to an exponent n, where your n is any positive integers, all right, as your x approaches k. So here it's just simply or basically getting the limit of your f of x, and once you have the limit of your f of x as your x approaches k, then raise it to your exponent. All right. So what will happen to this? This will become the limit of f of x, which is L, then raise your L to your exponent n. All right. So this is the limit of the power of the function. All right. What will happen to this function if you get the root of or the limit of the root of the function? Let's say, for example, you're going to get the limit of the nth root of your function f as your x approaches k. All right. So what will happen to this is you're not going to get the limit of the nth root. All right. So you just get the limit of your f of x as your x approaches k before you get the nth root of this. All right? Para hindi ka ganun mahirapan. As your limit of your function f is equal to L, then that's the time that you're going to get the nth root of your limit. All right? So basically, if you get the limit of the root of the function, you just get the limit of the function before you get the nth root. All right? So this is the root or the limit of getting the root of the function. So what do you think will happen if you're going to try to get the limit of the constant multiple? Or let's say you're going to get the function that has a constant. So the limit of your f of x, this is your function, and it has a constant c. So what happened here is your g of x has been replaced by c. All right? It's just getting the limit of the product of two functions. Ang nangyari, your C here is just a constant and it is not a function. So what will happen here? Again, it is just the product of two functions. You distribute the limit. You have the limit of your constant as your x approaches the value k times the limit of your function f, all right, as your x approaches k. And we all know that in the first part of this video that you have, when you have your limit, if you're going to get the limit of your constant as your x approaches k, we all know that it is c because it is defined in the first part of this video times the limit of your f of x, which is f. All right. So simply, you're going to get the product of the constant and the limit of the function. Now, these are your limit laws, and in that, let's see how can we put all these limits together in order for us to compute for the limit problem that is given in the first part of this video. All right. So the computation for this limit problem will be included in the next video that has 1 to 2 examples in each particular limit law for you to be familiarized by this new concept. All right. See you in the next video.